Hello friends, up to we complete exercise 4.1. Now today we are going to prove theorem on angle between the lines. So the statement of theorem is, if theta is the acute angle between the lines given by ax square plus twice hxy plus by square equals to 0, then prove that tan theta equals to in mod 2 times under root h square minus ab upon a plus b if a plus b not equals to 0. So see the proof. Let m1 and m2 be the slopes of lines represented by ax square plus twice hxy plus by square equals to 0. We denote this as equation number 1. Now if m1 and m2 are the slopes of line passing through the origin, therefore we write its equation as y equals to m1x. From this we write m1x minus y equals to 0, and second equation y is equals to m2x. So from this we write m2x minus y equals to 0. Now these are the two equations, the line passing through the origin. So we find its combined equation as m1x minus y into m2x minus y equals to 0. So after multiplying these two brackets, m1 into m2, m1 into m2, x into x square, then multiply by first term to second term of second bracket, m1 into minus m1 into xy, then multiply by this minus y to this first term of second bracket. So we write here m2 xy, then minus minus plus y square is equal to 0. Now we take minus xy common from the second and third term. So we write here m1 into m2 x square minus, in bracket, here term is m1, here term is m2, after taking xy common with minus sign. So we write here m1 m2 x square minus m1 plus m2 xy plus y square equals to 0. We denote this as equation number second. Now equation 1 and equation 2 are the equation of same lines. So we compare the coefficients, comparing the coefficient of both equations 1 and 2. So see the coefficient of x square in first equation and coefficient of x square in second equation. If we consider the equation second first, so we write for all ratios terms, or we can say coefficients of second equation as m1 m2 upon. So the coefficient of x square is a here, coefficient of xy is minus m1 plus m2 upon coefficient of xy is here 2h. So we write 2h is equals to coefficient of y square is 1 here. So we write 1 upon coefficient of y square is b here. So if we equate this first ratio with this last ratio, so from this we write m1 into m2 upon a is equals to 1 by b. So we calculate here m1 into m2 is equals to a by b. That we already use for solving the problems. Now if we compare this second with last ratio, therefore minus m1 plus m2 upon twice h is equals to 1 by b. So from this we write m1 plus m2 is equals to twice h by b. So after transferring this minus sign to right hand side, we get m1 plus m2 equals to minus twice h by b. Now we have to find the acute angle theta. So for that, if theta is acute angle and if slopes are m1 and m2, then we know the formula tan theta is equals to mod m1 minus m2 upon 1 plus m1 into m2, comma m1 into m2 not equals to minus 1, because when this value is 1 minus 1, then this term 1 minus 1, that is 0, so any number upon 0, that is not defined. So we have to write here condition m1 into m2 not equals to minus 1. That means that line not perpendicular to each other. So for this we have to find the value of m1 minus m2. We have the values m1 into m2, we have the values m1 plus m2. So we have to find values from these two values. So we write the formula for that. So we use the formula m1 minus m2 its square equals to m1 plus m2 its square minus 4 times m1 into m2. So keeping the values of m1 plus m2 and m1 into m2, that we calculate here, m1 plus m2 is minus twice h by b, so we substitute minus twice h by b minus 4 times m1 into m2, m1 into m2 is a by b. So after squaring, square of minus 2 is plus 4, square of h is h square, square of b is b square minus 4a upon b. Now we require base same, so for that we multiply and divide by b here. So we get 4h square minus 4ab upon b square, because base is same. So after taking 4 common, we can write here h square minus ab upon b square. So this is the value of m1 minus m2 its square. Now in formula we require the value of m1 minus m2 only, and this value is in mod. So taking square root on both sides, we write here m1 minus m2 is equal to plus or minus square root of 4 is 2, square root of h square minus ab, we cannot calculate, so we write in the root, and square root of b square is b. Now we require the value in mod, so we take mod here. Therefore mod of m1 minus m2 is equal to square root of plus is plus, square root of minus is again plus, so we write in mod 2 times under root h square minus ab upon b. Now this is the value for m1 minus m2, and we have the value m1 into m2. So using these two values m1 minus m2 and this m1 into m2, in this formula we get the required angle. So we substitute these two values. m1 minus m2 is 2 times under root h square minus ab upon b upon value of m1 plus m2. Sorry, m1 into m2, that is a by b. So after cross multiplying in denominator, so we write here 2 times under root h square minus ab upon b upon, here after cross multiplying we get b plus a upon b. So b get cancelled, we write 2 times under root h square minus ab upon this b plus a, we write a plus b, and a plus b in denominator, so a plus b not equals to 0. So this is the proof for the acute angle between the lines ax square plus twice hxy plus by square equals to 0.